Ever wondered why reaching the moon is so incredibly challenging? Despite being Earth's closest celestial neighbor, lunar exploration is far from simple. In this video, we're going to delve into past moon landings, many obstacles faced along the way, and why is landing on the moon so complex. But before we dive deeper, quickly subscribe to our channel and turn on your notification bell so you don't miss out on any of our videos. Let's dive right in. Reaching the moon is an extraordinary challenge. Over 64 years, we've seen 44 moon landings with notable successes and setbacks. Among them, 22 missions didn't go smoothly, with countries like the USSR, the USA, Japan, Russia, India, China, the European Union, and Israel encountering issues. But the moon has also witnessed remarkable successes. There have been 15 soft landings where automatic spacecraft touched down gently. The USSR, the USA, and China made significant contributions here. The Apollo program stands as a witness to human achievement, with 6 successful soft landings of spacecraft carrying astronauts. All parts of the USA's Apollo missions marked our closest approach to another celestial body. Let's talk about the key Apollo missions and any issues or challenges they faced. Apollo 1 was supposed to be the first crewed Apollo mission, but it ended tragically on January 27, 1967. A cabin fire during a pre-launch test resulted in the deaths of all 3 astronauts, Virgil Grissom, Edward H. White, and Roger B. Chaffee. The fire was due to electrical issues and the highly oxygen-rich atmosphere in the spacecraft. Apollo 7 was the first successful crewed mission in the program. It was mainly a test flight in Earth's orbit, and it went smoothly, demonstrating that the spacecraft could carry astronauts safely. Apollo 8 was a big step because it was the first mission to orbit the moon. There were no major failures, and it gave humans their first glimpse of the lunar surface. Apollo 9 was focused on testing the lunar module in Earth's orbit. It was successful, and no major issues occurred. Apollo 10 was like a rehearsal for the moon landing. It journeyed to lunar orbit and tested the lunar module to within 15.2 kilometers, 9.4 miles, of the moon's surface. Apollo 11 is famous for being the first successful moon landing in 1969. Neil Armstrong and Buzz Aldrin walked on the moon. It was a remarkable success. Apollo 12 followed Apollo 11's success, but it faced an early setback when it was struck by lightning during launch. However, the crew overcame this issue and successfully landed on the moon. Apollo 13 is well known for a near disaster. An oxygen tank exploded, causing the mission to be aborted. However, the astronauts and ground control worked together to bring the crew safely back to Earth. Apollo 14 was launched on January 31, 1971, and completed the 3rd human landing on the moon. Apollo 15, 16, and 17 also went to the moon, and they had their share of challenges, but none of them faced major failures. They conducted experiments and collected valuable data. The Apollo program was a significant achievement in space exploration, and while there were challenges and failures along the way, it also showed the determination and problem-solving skills of NASA and its astronauts. While there haven't been any failed moon landings involving humans after the Apollo era, there have been a few unsuccessful robotic moon landing missions. Here are a couple of notable examples. The Soviet Union made several attempts to land spacecraft on the moon as part of their Luna program. One of the most significant successes of the Luna program was Luna 2 in 1959, which marked the first human-made object to reach the moon's surface. Luna 9 in 1966 was another milestone, as it became the first spacecraft to successfully transmit images from the lunar surface back to Earth. While the Luna program had its share of failures and setbacks, it also contributed valuable data about the moon and paved the way for future lunar exploration efforts. China's Longjiang 1, 2018. As part of China's Chang'e 4 mission to the moon, 2 microsatellites, Longjiang 1 and Longjiang 2, were launched in May 2018 on missions to conduct ultra-long-wave astronomical observations in lunar orbit. Longjiang 2 reached its destination, but Longjiang 1 experienced problems that prevented it from leaving Earth orbit. Recent attempts to touch down on the moon, a feat first accomplished nearly 60 years ago, the former Soviet Union's robotic Luna 9 probe have been particularly fraught with failure. But on August 23, an Indian spacecraft, for the first time, successfully landed on the surface of the moon. The Chandrayaan-3 mission, which launched July 14, delivered the Vikram lander and the Pragyan rover to the south pole of the moon, a region thought to contain water ice. Such reservoirs of water ice would provide a crucial source of not only drinking water for any future lunar inhabitants, but also hydrogen for fuel. This was the country's second attempt at a lunar landing, following the crash of Chandrayaan-2's lander in 2019. Vikram's landing catapults India into a rarefied group of nations that have successfully made a soft landing as opposed to an uncontrolled hard landing on the moon: the United States, the former Soviet Union, and China. The success of the mission, however, follows close on the heels of recent failures. On August 19, Russia's Luna 25 lander crashed into the moon. The car-sized spacecraft had been orbiting the moon for several days when, according to Russia's space agency, communications were lost after the craft fired its engines during pre-landing maneuvers. Luna 25 was bound for the vicinity of Boguslavsky crater near the moon's south pole, where it would have studied the moon's surface and tenuous atmosphere. Earlier this year, on April 25, Japan's Hakuto mission 1 lander also crashed on the moon's surface. According to iSpace, the private company that developed the mission, the crash occurred because onboard software miscalculated the lander's altitude above the lunar surface. The lander was slated to touch down in Atlas crater on the near side of the moon and study lunar dust. In 2019, an Israeli nonprofit organization, SpaceX, attempted to land the Beresheet spacecraft on the moon. Unfortunately, during its descent, it encountered technical difficulties and crashed onto the lunar surface. But why is flying to the moon so complicated? Regular flights of astronauts to the ISS and the launch of more and more satellites into space can create the impression that it is not so difficult to fly to the moon. But for this to be done, it is necessary first to raise the orbit of the spacecraft so that its highest point, apogee, is behind our natural moon. For this, it is necessary to gain additional speed, which in turn leads to very high fuel consumption. In addition, after flying around the moon and returning to Earth, the spacecraft will still not be able to parachute down on it. To do this, it must first slow down, which also requires additional fuel. The moon is constantly moving in its orbit, and the speed of its movement is constantly changing because this orbit is elliptical. Therefore, all stages of the flight to it must be calculated beforehand to meet it at the right point. Just to fly to the moon and get into it is not enough to make a landing. If the spacecraft does not reduce the speed, it will simply crash on the lunar surface. This is often called a hard landing. A soft landing is called when the spacecraft does not collapse and continues to function. Reducing the speed of landing on the moon is both harder and easier than in the case of Earth. On the one hand, it has no atmosphere, the friction of which can be used for braking. On the other hand, the acceleration of free fall, which accelerates the spacecraft during descent, is much less here. Therefore, lunar probes rely on their jet engines to make a soft landing. Despite its relative proximity of just under 400,000 kilometers, the moon is a challenging target for spacecraft seeking to land. That's in large part because our nearest celestial neighbor largely lacks an atmosphere. The moon has no significant atmosphere, which means there is no air to provide aerodynamic lift or to help slow down a spacecraft during descent. This necessitates the use of rocket propulsion systems for a controlled landing. The moon's gravity, while only roughly 1/6 that of Earth's, is strong enough to have a deleterious effect on a crippled spacecraft in free fall. Spacecraft landing on a comet or asteroid have it easier because those bodies' gravitational fields are generally so weak there's little danger of a crash. There's also the challenge of determining a safe landing site. An area that appears smooth as seen from orbit might be littered with boulders or other obstacles. A spacecraft's software must be capable of evaluating the terrain on its own. Relying on human operators back on Earth isn't feasible because there's too long a lag in communications due to the finite speed of light. you're always 2.5 seconds behind. The moon is quite far from Earth, at an average distance of about 238,900 miles, 384,400 kilometers. This distance presents logistical challenges in terms of communication, navigation, and the time it takes to reach the moon. The moon's surface is covered in fine lunar dust, which can be challenging for landing gear and equipment. Temperature extremes, radiation, and the absence of breathable air make it a hostile environment for humans and equipment. Despite these challenges, successful moon landings have been achieved, primarily through careful planning, advanced technology, and the expertise of space agencies and their teams. Advances in robotics and autonomous landing systems have also helped make lunar landings more reliable. What do you think? Let us know in the comments section below, and don't forget to like and subscribe to our channel for more updates. Thanks for watching.